Hello, my name is Ralf Niklaus. I'm trainer at WABCOWÜRTH. Have a welcome to the WABCOWÜRTH Web Event. Today our topic is the W.EASY ADAS Calibration. Therefore, as I'm not willing to do it alone, I have invited a colleague. He will introduce himself.
Yes, hello Ralf. Thank you very much. Hello participants. My name is Markus Richter. I'm responsible for the key account management of the Autoglass customer, and therefore I'm quite a lot in touch with the requests of how to calibrate the lane assistance. In this case, I brought today our W.EASY ADAS calibration with me. This is our solution to calibrate the driver assistance systems, in this case the lane assistant, as it is driven by the camera. Our solution, as you could already see, is very mobile. The focus clearly is here to do the calibration at the customer's workshop, because those are the general requests we have. You can use it in your workshop as a fixed station as well, not a problem. Just push it in a corner where you can store it and bring it back when you need to use it. But it's, as you can see already, stacked on a trolley. Everything is together, combined. And Ralf will now demontate the Volvo target, the Volvo Renault target. As you can see it here already, the Volvo Renault target is needed on all trucks of Volvo and Renault, as mentioned. Why do you need to calibrate the camera here in this case? I mean, we should mention this at least. We have the two situations. We have one legal situation and we have a manufacturer situation. The legal situation is clearly there is an EU regulation at the beginning of 2016, end of 2015, that heavy trucks have to have a driver, has to have a lane assistant and a brake assistant. So in this case, we have a camera who is steering the lane assistant, and this is the legal situation. All trucks from that age on have to have the camera assistant. The regulations from the manufacturer, and this is now the interesting part, because we get a lot of requests of where is it written that I have to make a calibration? Where is it signed in a legal paper on law? Where is the calibration that I need to do? It's not written down. It is in a manufacturer's instruction, and this is important to say, because the situation with the driver assistance is that after significant repairs, and you have the requests during your trainings as well, general repairs are for the driver assistances.
For example, exchange of the windshield. For example, a vehicle had a crash on the front end. Other possibility, the rear axle had to be aligned in general, or the front axle as well. Then that's a topic when you must do a calibration of the camera system.
Exactly. And this is defined in the instruction of the OE, of the original equipment manufacturer. They have clear guidelines that after such a repair, the camera has to be calibrated. The way it has to be calibrated is clearly written in our software down, because our software fulfills the OE standards. So you are absolutely on a secured side of how to calibrate, and if you calibrate, that the job has been done with a calibrated, or with a not certified, but with a tool that is aligned with the OE regulations.
Also, nevertheless, as we are using our software in that case, you will receive a documentation of the successful calibration.
Exactly.
That's needed afterwards. If you repair, for example, the windshield and want to get paid your bill by the insurance, they would like to have a protocol that all the work is done. To see that the windshield is exchanged, there's a photo enough. That's clear. Easy to see, it's in your windshield in. But the calibration is done properly. Therefore, you need a protocol out of a system which we deliver with our W.EASY system.
Exactly. So now we have on your side, please push it over, the MAN Scania target. As you have seen before, the Volvo Renault target, you see now the MAN Scania target. Both brands are within the Volkswagen group, the truck brands, and they are calibrated with this target in 2 different steps. So in this case, we have now the first position where we press the calibration button, and during the calibration is running, we get asked to move the target. This is the near distance we calibrate, and Ralph will now pull the tool back or push the tool back until a certain point, because we have another target here in the back, so we cannot turn it around the full way. But then you have 1 meter distance. This is the second step you have to calibrate. So you avoid to adjust the whole tool once more, and this saves you a lot of time. So 1 adjustment with 2 steps of calibration, simple and easy. This was MAN Scania. So those 4 brands I mentioned, Volvo, Renault, MAN and Scania, are the brands that we calibrate in a static way of the heavy trucks. There are 3 additional brands, Mercedes, DAF and Iveco. Those brands or those trucks are calibrated dynamic. So in this procedure, you link onto the truck with the software, you type in the height of the meter, you choose the calibration, you type in the height of the camera and press on start, and you have to make a test drive afterwards to fulfill the calibration. So Ralph is now moving up our target from Volkswagen for the MAN TGE for the transporter. On the back of our plate, as you can see here with the cross at the back, you see 2 spots. Those 2 spots belong to the Mercedes calibration. In the center is a little cross. This target is needed to calibrate the Mercedes Sprinter. You get this target basically with 2 targets, or you get 1 equipment with 2 targets. And as you can see it here now, we have the the Volkswagen Transporter target. You can calibrate an MAN TGE, you can calibrate a Crafter or other transporters from the Volkswagen group. Ralph will push it now up on the trolley here. We adjust it, we tighten the screws, and this is important because we need to work as exact as possible. So now we will put the magnet on it that our target is stiff on the holder, and we will now adjust the target roughly in front of the TGE. Okay.
Meanwhile, I will open the software. In there, you will find the instruction how to set up the target properly,
Yes,
with the right measurements, the right distances. And we take a look together in it and do it step by step.
exactly.
So first step, select the vehicle, TGE, MAN LCV. Vehicle is selected. We prepared already our WABCOWÜRTH box is plugged in the vehicle. The vehicle ignition is on. That's important for the diagnosis. The first thing I should do, especially as an autoglass company, I should start the scan to gain an overview over the status of the vehicle, of the built-in components.
Just to avoid any discussions with your customer afterwards, why the Christmas tree inside of the car, the truck, is shining, to ensure that all the lights that are on there have been on before. Make the scan, save the scan, and show it back to the customer when he asks or when he has a request or complaint that some of the lights are on, and he blames you that now the failure is up on you. You have the scan, you have the security that everything is done. Brilliant.
The second topic, why it's very important. If there are systems with failure which are communicating towards the camera, for example, the radar system have a failure, then you will have problems to calibrate the camera.
Yes.
These are topics which you need to find out previously and then communicate to the mechanic or to the vehicle owner. These are topics which have to be fixed before you even start to replace the window or the windshield.
Exactly.
So meanwhile, the scan is almost done.
Yes. At the end, we see the camera module for the front. So as soon as this is a green OK, we will get the information that the scan is concluded. And the green OK is also our indication that we can proceed with our calibration. So now the scan is done. Ralph will now save the scan. It's locally stored at the laptop, but you can create a PDF file out of this scan, send it via email around, or even print it out if necessary. Yeah, to give it to your customer or to put it to the invoice and turn it into the insurance company. As soon as the scan is saved, we will jump into the calibration. And Ralph will now explain us step by step of the instruction how the calibration is done.
There are various ways how you can go to the calibration. You can just keep the open scan, open the camera module in the front, so you come into the fault memory. In there, you will find function and can go to the calibration. You also can use our search function, type in camera calibration or only camera, and you will be guided to the same position. So as most of you maybe know, there are a lot of variations possible how to reach to the goal which you are looking for. In our case, we received the proper place, calibrating camera with the WABCOWÜRTH ADAS calibration. It's also possible to calibrate it with the OEM tool. So
yes,
or vice versa, use the OEM software with our tool. You can combine it however you want. The reason is, as we do it on the same way as the OEs do it, so we have the conformity about that, and then it makes no difference which combination you are using.
And it's important, especially on the Volkswagen group, that you fulfill that your calibration tool is going onto the geometric driving axle. Some of our competitor tools does not fulfill these regulations. Just clarify it in case you want to make a purchase that your system fulfills the geometric driving axle. We can do it, and therefore we can calibrate the Volkswagen TGE today and also the 4 other static brands because they request the geometric driving axle.
What is important here in the instruction file, the first part explains you what we already spoken about. When do we need to do a camera calibration? Afterwards, it's important notes what you have to take care. We will talk about these topics a little bit later on when we have finished and we see how many time still stays open. If not, you have the text written in here. So possible causes when we could receive a failure, what topics should we take a look on it?
Exactly.
And very important, the test conditions.
Absolutely.
So the vehicle calibration equipment must be positioned on a level surface with good illumination. Okay, here in the studio we have it.
Yes.
Leveled, don't means nivelated.
Exactly.
Imagine, for example, you have a floor which falls a little bit downwards because the water could go down to some place where it runs away. Then your tool have to be set up on the same angle. So the floor is all the way with the same angle. The vehicle is angled as well as the target itself. So you have here a parallelity. That's the important topic.
Finally. Yeah, the floor has to be even. And if the floor is even and the tool is on the same even floor where the truck is standing on, we can fulfill a calibration. This is important. And even doesn't mean that it is in a flexible way.
Yeah, not torqued.
Exactly, torqued. Yeah, even is okay if it is in this way, or this way.
Yep. But until a specific angle, which is written in there, it's in range. some other topics. Talking about a bigger vehicle with air suspension, for example,
Yes.
vehicle should be in the niveau of driving. So not lowered, not rise in standard condition.
Driving level,
Talking
exactly.
about a semi-trailer, a semi-truck, it have to be disconnected from the trailer.
Yes.
So empty vehicle or regular driving status. And some other points which you can read down there. Fulfill the test conditions, please. Then you get safe. You are able to do a proper calibration. What else do we have here? Depending on the vehicle, especially on Volkswagen, you need different calibration board heights. You need different distances, different ways how to step forward due to the calibration. Here we see the line, which distances we need, which measurements we need to do, and how and where to measure and how to build up the tool. Up here we have a bolt printed HTML file, which I click on. It opens an additional window. On top here, you can go to the middle button, you have the help file or the instruction file, and on the right button you have the help file. So let us do together what we have to do. We need a diagnostic tool. We got it. Diagnostic software, we are in. Calibration rig together with the universal holder for transport vehicles and manufacturer specific target. We have it there.
Yes.
You brought it with you. Okay, the base is mounted with the specific rig. Next step, we should enlarge our two frames and build on the laser targets. So the laser targets and other stuff, which is, yeah, in the box here, it's shockproof, it's mobile, it's stored on a good way, so nothing could happen.
Highly mobile, as one of my favorite colleagues would say.
Okay.
So we will proceed.
First thing, the laser scales, which we have here, they got a sticker with a color dot on it. So that means on the target itself, you will see also the sticker, the proper one. Hope it's visible. It is visible. So red to red, and you have green, so green to green. Another topic, you have to pull it out. No. First lock is for transport. Release the lever, pull it out to the next step. It's the proper one for cars and for LCVs. We have two additional ones for wider vehicles. On the laser scale, you will see, yeah, how it's called this, I don't know.
The latch.
A latch which will fit into the C profile. So open the screw or the nut, go through the hole, position it properly, tighten the bolt again, and the laser target will be inside of the profile. So that makes sure it will stay exactly parallel towards the holder. Same is done on the other side. Nothing else to explain here.
Meanwhile, I picked out the laser, the central laser from our case. The laser is placed here in the center of the tool, and it is a help to centralize the tool roughly in front of the truck. We will come on to this in the next steps.
Okay, that we have. Next topic, we have the mounted target already. We have to set up the proper height. Okay, where do I get the height? As I explained before, down here, calibration board height, 1260 millimeters. from floor to the under level of the target. So we have a measure tape in here. Thousand 260 millimeter. We have the proper size. Why do we have the proper size? We did the calibration already yesterday. In the rear end, maybe you saw it before, we have a little screw where we can adjust the height of the whole holder to adjust the target height. So that's done. What is the next step?
Maybe you put your computer down at the front desk. So
You
that
put
we
the
can
box
work
down
towards
there.
our
Yeah,
participants.
okay. A lot of them have seen me already, so maybe it's not so important.
Yeah.
Turn on the lane laser, vertical line, and center the calibration rig. The lane laser to adjust it into the middle.
I will place the laser now roughly in the center of the A of the MAN, because this is then the center of the transporter.
So maybe I got an idea how it could be more visual. Maybe you hold the paper in before so the laser is visible. Yeah, that looks great.
Important is to say, when you have placed the laser roughly in front of the truck or the van, turn it off, because it might disturb the camera later on during the calibration.
Next step, turn off the line laser. It's on it. We have done it. Measure the height from the ground to the wheel hub center. So to the front axle, the height.
So in this case, we have to mount our...
It's not necessary yet. You can measure it right here. You can do it as well with the clamps. No problem. We do it like it's written in the manual.
And it says 36.
36. So we need this measurement as we have here the space for 2 bars. We have to measure it exactly in the middle, the 36. We should have, no, should go here. It's less than the lower.
Yeah, roughly. It suits.
It suits. Perfect. So we did it yesterday already properly. The height is adjusted. You see here 2 screws on top, 2 screws underneath, and there you can adjust the height of the whole bar in the frame. This grants us to have always the right angle of 90 degrees towards the floor and the right angle, the parallelity towards the base plate. Okay, we got that. What is next step? Oh, I just explained what we see in pictures now. Great. We do it. We did it. Install the clamp and mirror scale unit and the tape measure holder. So that's the clamp on the wheel.
You want to say something to the clamps as well?
I can do so. You go to the other side then and
Yes.
position the other one.
I will.
That was the wrong side, sorry.
Okay.
No problem. Okay, the clamp. You have here the thread which works vice versa. If you screw it, it's a little bit hard to see, but it will move the plates simultaneously, inside or outside. So the center will stay always in the center of the hubcap. On the front, the pins, we have 3 possible mounts. So this grants us that we can cover rims from 11-inch up to 25-inch. So you can cover from a small LCV up to a big truck or bus, whatever. On the pin, the front, if it goes in that way, means you would like to mount it on steel rim, turned it with 180 degree, you will mount it on a mag rim or aluminum rim. And if you pull it out and turn it vice versa, you see here, you can go surrounding a hubcap. So no need to dismount a hubcap. I'll plug it in, screw it in. So set up on the bottom, screw it out a little bit, tighten it smoothly. There's no need to make a big force on it. Thank you for the mirror. Tighten the mirror scale. And on the outside, you have another hole where you can plug in the tape measure holder. You give me the tape
Here we go.
measurement, one end at least. Thank you. The holder, just hook in the tape, and then we have to measure the distance from the scale towards the front of the.
In this case, we have 2 meters.
Great.
We have on the other side 2 meters as well, as I have checked it meanwhile.
Great.
So sometimes it works out, even though it's a Saturday morning.
Yeah, that's probably the case.
Freshly and
already in weekend
slept
mode.
well, right?
Okay. What does the software tell us for the next step?
Go for it.
Yep.
I will just demount our holder.
Yep. Okay. So it means we have measured the distance, set it up to the 2 meters, wide 2 meters. In the instruction, we see distance from the center front axle to the calibration board, 2 meters, plus minus 25 millimeters. That's our tolerance, which we can use. What is the next step? Mounting the clamps with the mirror scales on the rear axle. That's what we have.
Participants have seen it already. Björn has shown it. I did it already. So I have moved it now. We need to move it on the other side as well. And I will turn on the laser here. As you can see, the laser now will reflect back to our mirror. Great.
So what we see, unfortunately, it's not hitting the mirror. See, it's just on the corner. That means Marcus has to turn out the laser plate, or well, the whole body a little bit outside, so the laser point comes to the outside. Okay, that's quite enough already. We have to ensure on both sides the laser point is hitting the ground, the plate. Now, be careful while you are turning the mirror side frontward. You will see the red laser dot, which moves slowly, well, depending how fast I'm turning, towards the plate where Marcus is sitting.
So we have a 17, 18 here and a 25 on this side. So
18 and 25 is 43. Half of 43 is 21.5. That's our measurement which should reach.
So I now lifted up the tool once more with 2 fingers and with this little bar underneath and moved it smoothly to 20, what was it, 21?
21.5.
21.5.
So we calculated properly. On the other side, it's the same measurement.
So the parallelity is now done.
Means the angle of the tool towards the rear axle is exactly the same angle. So they are parallel now. Next step will be to set it into the center properly. Roughly, we did it with our line laser. Now we have to do it with the proper tool. He did exactly what it's written in the manual. Now we have to turn the mirror scale from the mirror side towards the scale, and do that always towards the ground, towards the floor, so you will be safe with your eyes. Sorry that we are taking a little bit over time on that case. I hope it's okay for you.
We have a 6.5 on this side, and we have a 12 on this side, or 11.5 it is. So in this case, we need to hit the 9.
The 9, yeah.
And now I take the bar and I do not lift the tool up. What I do now is I push it in the direction. Therefore, the wheels are stiff and I can easily now push the laser onto my mark. In this case, 9 should be fine. Let me quickly check it on this side. Here we go.
Great. So we did all the setup from our tool, conform to the manufacturer demand, go back to the instruction. We have set all these up. We read the note and understood it, hopefully. Continue. That's a precondition. Engine off, ignition on. We did it. If not, we could not have the communication towards the vehicle. Okay. System asked me if I would like to perform the calibration. Yes, that's why I'm here. Have you set up the calibration rig with accessories? Yes, we did it. Now measure the body height from the upper edge of the wheel arch to the ground on all 4 wheels.
Starting with the wheel.
Starting with the wheel front left.
Front
so
left.
The tool indicates us in which direction we have to go around the car and which measurements we should make.
So in here we have an 82.
82. So 820 millimeters. Next one is front right.
Front right is 82.
82. 820. Then we have the left rear.
Left rear is 83.5.
835. Okay. And the last one, right rear.
Is 84.
840. Okay. Distance to the calibration board, it was 2000 millimeters, 2 meter, which we measured. So we make 2000. Okay. The values are written into the control unit. You see it on the box, is communicating to the vehicle. Now, these fall, here you have an overview over the already stored values. You can confirm them or not. So just verify if they are proper. Okay, that's what we have written in. Searching for the calibration board means the camera is trying to find the target. Successfully calibration, so everything runs well. We get an overview of the measured values after the calibration. Okay. And here we have the protocol, which I will save immediately towards the same vehicle. It remembers all the data, save, and it is stored in our memory module.
So now you have seen how a proper calibration worked out. This is not always the case. So we have a lot of issues that might cause a not working calibration. Nevertheless, it is important to fulfill step by step the instruction. And we have other conditions as well that can cause a calibration that did not work out. For example, we have the vehicle itself, a technical vehicle that can cause a lot of failures. We have the surroundings, such as light, if it's too bright, if it's too dark. Those can also cause calibration that doesn't work out, as well as if we have, and this is also something in the background, for example, other targets hanging. Now in our case, it's a little bit behind the tool, but sometimes in a workshop they hang in the back of the wall. So this can also irritate the camera and cause, basically not the working calibration. So these are some fault issues that you may consider when this calibration did not work out. Ralph has now opened up the scan via PDF.
It's not the scan, it's the protocol.
The protocol, yes, the calibration.
So on the third page, you have the visual information. The camera calibration was successful. Don't forget to put in your name, sign it. And last but not least, the fourth page, it's the documentation that you have done already, also a test drive. That's important. After the calibration, you must perform a test drive to ensure the system is working.
So now, after you have done your job and you can demount the tool, don't forget to make an outgoing scan, just to ensure that you have documented the status of the vehicle when you turn it over to the customer, so that you can compare the incoming scan to the outgoing scan, and you can see then, okay, is there an additional failure or not? In case everything is right, brilliant, then you have a clear documentation towards your customer in case he complains about failures of his truck or transporter.
In this case, if you stay online a couple times still with us, you will find out that the scan will find 2 failures in the radar system after the calibration. That's a typical Volkswagen issue. Due to the camera calibration, the communication to the radar system will get lost. And that's the reason for those 2 failures. So when the scan is performed, just delete the trouble codes and the system will stay in green completely, and you can hand out the vehicle to your customer.
Yes, and all the ECUs are running properly. This is important to say. Exactly. You don't have to calibrate any radar. Everything is fine.
Yep. If you have any question beside that what we have been talking, don't hesitate. The chat function is available and you can type in all your questions. We have some specialists here behind the scenes which will answer even after 15 minutes still your questions if you are still in there. From my side, nothing else to add on?
Yeah, thank you very much for your patience and for being on a Saturday online with us and checking out the calibration. Thank you a lot, and we hope that you enjoyed it and learned a bit and maybe interested about our solution.
Same from my side. Thank you very much. Sorry for the overtime, but I think the information we spread out was worth to stay a couple minutes longer online.
Have a nice weekend.
Bye-bye.